So wrapping up chapter 11, we're going to look at some word problems that go along with sequences and series. And the biggest trick here is determining whether they are going to be arithmetic or geometric sequences. So looking at this, so we have to decide based on the words what the situation is telling us. Is it adding or is it multiplying? So looking at this first one, Jerry deposited $20,000 on in an investment that will give $1,750 for every year that the money stays in the account. How much money will he have in his account by the end of year 8? Now, this one is a little tricky because we are used to taking our n value. So this would be arithmetic because he's adding this amount, right? He's adding the 1750 every year, right? So that makes it arithmetic. And our initial value is 20,000. And typically for arithmetic, we take initial times our n value, our initial plus our n value times common difference. Our common difference here is the 1750. But because this is an investment, right, this is really year 0, right? And we want to know at the end of year 8. So we are actually, instead of n minus 1 this time, we are going to go with just the full n value. So this one's a little different, right? So 20,000 plus 8 times 1750. So $34,000 at the end of year 8. And if we think of it in terms of repeated addition, right, $20,000 goes into the investment, right? They're not going to pay you out until a full year has gone by. So that's year 1's value, 2, 3, 4, 5, 6, 7, 8 years is the 34,000, right? So when we start applying these concepts into real life, it can get a little messy with determining n values. There's a stack of logs in the backyard in problem 2. There are 15 logs in the first layer, 14 logs in the third layer, 12 in the fourth, and so on, with the last layer having 1 log. How many logs are in the stack, right? So might need to start off by drawing a little picture, right? 15, 14, 13, 12, and so on, right? 15, 14, 13, 12, and so on. Right now, they say this is the first layer, right? And I actually drew this upside down, right? Your stack of logs would look like this, right? With logs. But if we draw this upside down, right? We keep going with that concept. Our last row is going to have 1 log, and that would be the 15th row, right? So either way, there are 15 rows, and this would be a series problem, right? So S15, and it's arithmetic because it's decreasing by 1 each time, right? So this would be 15 over 1, or 15 over 2, sorry, times 1 plus 15, right? Because there's 1 log in the top row, 15 logs in the bottom row, 15 total logs, right? So that summation formula, n over 2 times a1 plus an, right? So in terms of this problem, 15 rows, top row and bottom row get added together. So we get 15 over 2 would be 7.5 times 16, 7.5 times 16. 120 logs in the stack, right? And you could do that on your calculator, 15 plus 14 plus 13 plus 12. You could do that pretty quickly that way as well. So in a piggy bank, bingo dropped $1 on May 1st, and $1.75 on May 2nd, $2.50 on May 1st. He had $1. $1.75 on May 2nd, $2.50 on May 3rd, and so on. So each day he is dropping a new amount. That's not the total sum, but the amount he's putting in his piggy bank each day. He does that for the duration of May. So we have a couple of things here. We have part A. They want to know how much is he going to put in his piggy bank on the May 19th. So this is again an arithmetic sequence because we're adding, right? So we're going to use those arithmetic formulas. This is going to be AN equals A1 plus N minus 1 times the common difference, right? So our first term is $1, and then the 19th term, so we're going to go 19 minus 1 is 18, and each day he is putting 75 cents more than he deposited the previous day, right? So our common difference is 75. We go to the calculator to get that total for the day. So he would have put $14.50 into his bank account on May 19th. Part B asks, what was his total deposit in his piggy bank for the entire month of May? So in this particular case, it does not have anything to do with Part A, but we are going to have to, right, we need to do our summation. There's 31 days in the month of May, so 31 over 2. First term plus last term, which we don't know yet, right? So I can use that formula to find the term of a sequence. 31st term would be 1 plus N minus 1 times the common difference of 75 cents, right? So that would be $23.50, what he put in his piggy bank on the last day of May. So we need that there for to find our sum. Plugging that into the calculator, we would get $379.75 in his piggy bank by following that little step all for the month of May. Problem 4, kind of what we've been used to, 20 rows in a concert hall, 25 in the first row, 27, 29, and so on. They want to know if you charge $2,300 per ticket. I don't know who's performing that you're going to get $2,300 a ticket, but somebody, if you sell out the concert hall, how much money is going to be taken in for sales? So 2 steps, we have to figure out how many seats are in the theater, and then we'll finish out by finding that cost. So this is, right, a sum problem. So I am going to take my N over 2. So 20 rows over 2, 25 for the first term, except I don't know the last term. So I have to use the formula. A20 equals 25 plus N minus 1 times the common difference of 2, right? So 25 plus 19 times 2. 63 seats in the back row of the theater, which I am going to then put into my formula there. Right, so 20 over 2 would be 10 times 25 plus 63, meaning there are 880 seats, which is a pretty small venue. But then to find that total cost, I'm going to take the 880 and multiply it by the price per ticket. Again, that's a pretty high price for a concert ticket, right? But they're going to bring in just over $2 million in ticket sales. Right? So that is your total cost. Sonia has 55 blocks. She wants to stack all the blocks so that each row has one less block than the row below. She wants to end up with just one block on top. How many should she put on the bottom row? So she wants to build a pyramid, right, with her blocks. She wants to end up with one in the top row, and we don't know how many rows, but we know that she has 55 total blocks. So we could set this up with our sum formula for arithmetic. We could say Sn equals n over 1 or n over 2 times term 1 plus term n. Now, the problem is I know the sum already. I don't know the n value, and I don't know the last value. I do know that they would be the same. So I could plug this into Desmos if I distributed things out to clean it up. It would help a little bit, right? I could say 55 is equal to n over 2 times n squared over 2. That doesn't really help me. I could graph that. What I would do to solve this is just very simply say, I have 55 blocks, right? So in my calculator, I'm going to say I have 55 blocks. Okay, I subtract out row 1, top row, 1. Then there'll be 2, and then 3, and then 4, and then 5 blocks, right? I'm basically building my tower upside down, right? So now I have 40 blocks left in my stack of blocks. I use 6, and then I use 7, then I use 8, then I use 9, and then I use 10, and now I'm out of blocks. So there would be 10 rows, and the bottom row would have 10 blocks. So theater has 32 rows of seats. There are 26 seats in the first row, 30, then 34, and so on. How many seats are there in all? We would need to find the back row, right? So A32, row 32, is equal to front row plus n minus 1 times the common difference of 4, right? It's increasing by 4, 26, then 30, then 34. So plugging that into my calculator, I would get that there are 150 seats in that back row. I would then find my sum of the 32 rows is equal to 32 over 2 times 26 plus 150, right? First row, last row. Plugging that into the calculator, 16, 32 divided by 2 is 16 times 26 plus 150. Calculator has a mind of its own today. There we go. 2,816 seats in the theater. For problem 7, an 800 meter deep well is being bored, and it says that the first meter costs $250, and then they're going to increase the cost per meter by $50 for each subsequent meter, right? So the second meter is going to cost you an additional $300, and the third meter is going to cost you an additional $350. So it asks you to find the cost of the 750th meter. So to do that, we are going to use the sequence formula for arithmetic. So that would be AN equals A1 plus N minus 1 times the common difference. Now, our first value was the $250. Our N value is the 750 minus 1, which would be 749, and then our common difference is $50, right? So we get $250 initial cost, $250 initial cost, plus we are going 749 additional meters at an additional $50 per meter. So that that 750th meter is going to cost you $37,700. The second part asks cost incurred for the entire job, right? So we need to find the sum of 800 over 2, right? It's 800 feet deep times first value plus last value, but we don't know that last value yet. So I have to calculate it, right? A800 would be equal to 250 plus 799 times 50. 250 plus 799 times 50. $40,200 for that last meter being drilled, right? 40,200. Right now, I am going to say I need to do the 250 added to that and then multiply it by 800 over 2, which would be 400. And the cost then for the boring would be, it should have a comma there and there, $16,180,000. And you might think that sounds ridiculous. However, Fort Wayne just wrapped up a massive tunneling project to help with stormwater, and it cost about $500 million, about $500 million to do all of that work. So that cost is probably not too far out of line. Lastly, we have this toy. First year toy manufacturer introduces a new toy, super popular, and then they say it's going to drop off 10% each succeeding year. Find the total expected sales in the first 6 years. So to do that, I am going to use the summing formula for geometric series. So my N value is going to be 6. My A1 value is going to be the $4,950 times 1 minus my growth rate, which is really, since it's going to drop 10%, my growth rate is going to be 0.9, and then to the N power all over 1 minus my growth rate. Right, so that one's a little different than what we have seen before in our reviews, but it is a real world type problem. So as I enter this into my calculator, for 495,000 times 1 minus the 0.9 to the 6th power. And then I'm just going to go ahead and divide it by my denominator, which would be 0.1. I get 2319367.05. And so they're going to have $2,319,367.05 in sales of their toy over these 6 years. So that is our last problem for the day. Do not panic too much, because these problems are all significantly harder than what you will see on the test, but they are pretty true to life applications of our sequence and series work.